Children's, in this question or on this topic, what we study is this: pure solvent is given. It is having some specific value of vapor pressure. If you add any solute which is non-volatile, then its vapor pressure will reduce. And for that you have got only one formula. In the exams, they will ask any question, but all these questions will be based on only this concept and this one formula. What is that formula, children? Relative lowering of vapor pressure P1 standard is equals to W2 upon M2 and M1 upon W1. In any exams, whether it is JEE, whether it is NEET, whether it is state board exams, they are going to ask you only on the basis of this formula. So if you have understood the concept very well and practiced the numerical, then any question you will be able to solve. Children, if you have not understood the concept, then please go through the previous videos. There I have discussed the concept of colligative property, lowering of vapor pressure, each aspect of this one in a quite detailed manner. So let's begin with the today's topic, children. Today I am taking one more numerical in that direction, and you will witness that concept is same, formula is same. Sometime they will ask M2, sometime they will ask M1, and so on. So let's begin, students. The vapor pressure of water at 20 degree is this much. They have taken pure water and vapor pressure of the pure water at 20 degree centigrade. This is water, only water, so this is what? Pure solvent. Now vapor particles which are present will generate some pressure, that is known as the pressure of these vapors, that is vapor pressure, and its value is how much? 17 millimeter of mercury, which is a unit to measure the pressure. And since this is 17 millimeter of mercury and that is the value of the pure water, I can say that this is the vapor pressure of the pure solvent. 17 millimeter of mercury. Vapor pressure of pure solvent. This symbol indicates the pure solvent. Now they are asking, calculate the vapor pressure of the solution containing this much gram of urea and 50 gram of the water. Means they have taken 50 gram of water. How much water? 50 gram. And water is not present alone. It is having some solute particle. What are these solute particles? These solute particles are what? Urea. These solute particles are of urea. Urea is non-volatile. Non-volatile. What does it mean that non-volatile? Non-volatile means they will not evaporate. They will not vaporize. And what is their weight? W2. They have given us W2 value as calculate vapor pressure this much containing this much gram of urea. 2.8 gram of the urea. Now children, carbon's weight is 12. One carbon atom, you can say 1 mole of the carbon atom is having weight of 12 gram. That for oxygen is what? 16. That for nitrogen is what? 14. Hydrogen is 1, so 2 hydrogens are there, so I will write 2. Same here, nitrogen's weight I am taking as 14. For 2 hydrogens I am taking 2. Children, if you add it properly, it turns out to be 60 gram. This 60 gram is the weight of 1 mole of urea. 60 gram. You can say this is molar mass of urea. Molar mass of urea M2 is 60 gram. These values are given to us for nitrogen, for carbon, for oxygen, for hydrogen. Formula also given in the question. So with the help of all these things, we are able to calculate molar mass. Now children, W1, that is weight of the solvent, is also given to us 50 gram. 50 gram. There, even molar mass of the water, we all know it is 18 gram. Having formula of water H2O, oxygen how much? 16, hydrogen for 2 hydrogens 2 comes out as 18 gram. So molar mass of the water is 18 gram. They are asking you vapor pressure of the solution. Correct? Vapor pressure of the solution. Let's read the question. Vapor pressure of the water at 20 degrees 17 millimeter of mercury after adding 2.8 gram of the urea, now it becomes a solution. That one was pure substance, pure water. Now this is a solution. If you add some solute to the solvent, it becomes solution. This solution will have lower vapor pressure. Now vapor pressure is having lower value. But what that vapor pressure is? That is the question mark. This substance, now this solution is also going to have some vapor pressure. We denote it by P. What is that vapor pressure? Children, as I told you, for this entire concept we have got only one formula. Delta P upon P1 standard equals to W2 upon M2 and then M1 upon W1. To remember this formula, you remember only one thing, W2 upon M2. that is number of moles of solute. Others will be just reverse of that. W2 upon M2, then you write M1 upon W1, opposite to that. Now childrens, delta P is actually P1 standard minus P. Delta P is what? P1 standard, vapor pressure of the pure solvent, which is always higher, minus vapor pressure of the solution. Sorry. With the help of this formula, we are able to calculate delta P. Delta P, once you have calculated, P1 value is already given, then P we can find out. So children, let's first calculate delta P. First we will calculate what? Delta P. Delta P W2 M1 upon M2 W1. This P1 was here. I am taking it to this side. It comes in the numerator, P1 standard. This will remain as it is. Delta P will remain here only. Now children, delta P equals to, let's put all the values. 2.8 gram, that is W2, weight of the solute, into M1, molar mass of the solvent. P1 standard, the value P1 standard given us as 17. M2, 60 gram. W1, 50 gram. All these are the given values. Now children, delta P equals to 2.8 into 18 into 17 upon 60 into 50. I will write 6 5 are 30 and these two zeros I am writing. Correct? Dear students, I will take a round figure here. Now after 8 it is 5. So I will leave all other digits and I will make it 9. That is the standard rule. If suppose this number is 5, make it 9 and leave other things, right, like 2 9. But if suppose you get here 4, then forget everything, just keep 0.28, that's it. So this is the method how we take the round figure. Here it was 5, so I will write 9 and leave other things. Now a 0.2856 or 0.29, that is one and the same. That is known as the rounding of the figure. Now children, delta P equals to P1 standard minus P. P they are asking, I am taking P to this side. P1 standard minus delta P. This P is coming here, delta P is moving to other side. Now P equals to P1 standard. What is P1 standard, children? 17 millimeter of mercury minus delta P 0.29. Let's subtract it. 17.00 minus 0.29. Subtract it. 10 minus 9, 1. 9 minus 2, 7. Now this 6, this 1. So the P value is 16.71 millimeter of mercury. Dear student, this is the final answer. Now I will discuss with you how I did this logarithmic calculation. For this part, which I have written here separately, all the values which are present in the numerator, you take their log and add. Whatever is present in the denominator, you take their log and add. Here we have got only one value. So only we are taking log of 3000. Here I have taken log value as well. Children, when you see the log table, first you have to see before decimal there is only one digit. So its characteristic will be 0. Before decimal 2 digits are there. So characteristic is 1. 2 digit is there, so characteristic is 1. Here 1, 2, 3, 4. 4 digit, so characteristic is 3. Thereafter, you see this log table. Get these values from log table. Add them. See the log value of 3000. Subtract addition of this and this. After subtraction, whatever you are getting, here I have written bar 1.4558. Bar 1.4558. Take empty log of that and you will get this value. And after getting that value, here I wrote 0.2856. Then I made the round figure 0.29. Then we calculated. So children, practice these questions, even other similar questions given in your textbook. And from your likes, children, we get some encouragement. And we think that since we are going in the right direction, in the classroom it is direct conversation. But since in this era of video lectures, immediate interaction is not possible. So your likes will be a sort of interaction. Your comments will be sort of interaction. Good, bad, whatever. Support I want to give to your education, and whatever extra supports you need from me, you can write that in the comments. Whatever best I can do for my all students, I am here to do it. So keep on studying, children, and share these videos with your friends and help them toward the preparation of the 12th standard board examination. Any kind of the support, whatever you want, ask that in the comment box so that I can improve these lectures, these videos, and support you. So see you, children. Thank you.